We're here at M&M in St. Louis. Could you tell us a little bit about what Zeiss is showing this time around?
Absolutely. So I'm a material scientist that is working with Zeiss, and we're being focused on solutions for our material scientists, and particularly been very interested in the metals community, primarily because they have a very important job. So maybe give a background. Metallurgists have been looking at sort of the origins of atoms, namely how they form, deform, and eventually fail. Because what is forming at the kind of atomic level transcribes many orders of magnitude to making rebar, and then eventually that goes into a bridge. And so all of these really infrastructure are critical to our everyday lives. And so material scientists exist mainly to help build the future, and we're helping to support that with the analytical tools we provide with microscopes. So specifically, Zeiss really has a broad portfolio in terms of light, electron, X-ray, and ion microscopes. And it's, there's no one Swiss Army, right? And how do you make all of those instruments work effectively together, smarter, faster? It's all really what we're looking at to help our customers do. So primarily in the metals, with the light microscopes, we have a very wide array of kind of digital solutions. There's many types of standards that need to be abided to characterize steel grades, for example. But then what we can do now with a lot of these light microscopes is to use tools. One is shuttle and find that can link our light microscopes to our EM, so navigational. And so when you can find that inclusion in an automotive spring that you've observed in the light microscope, you can then take that really efficiently to an SEM to do more advanced, higher resolution, as well as spectroscopic EDS type data. And more so that we're now looking into 3D material science as well, with our X-ray microscopes to do computed tomography, as well as doing high resolution tomography in our focus ion beam, our cross-beam system. And doing that is important because you want to take large areas, so look at kind of large fields of view, see kind of defects that form, cracks that are forming, or even study materials in situ with our X-ray microscopes, but then focus in a region on there where you can get higher resolution in a crossbeam to do higher tomography, EBSD, all the types of analytical tools that are not currently available on an X-ray.
You're going to tell us a little bit about one of the new features on the X-ray microscopes, I believe.
Yes. So we've been trying to solve one of the problems in polycrystal materials, such as metals, and that is understanding the relationship of crystallography to its properties, especially in 3D in a non-destructive form. So we've developed laboratory diffraction contrast tomography with Erik in order to solve that problem. So it's been a great partnership, allowing researchers to look at the materials, correlate the properties it see in 3D along with its crystallographic properties in order to optimize them for materials design.
Okay, good. And so is this something completely new or something you've been working on for a long time?
It's something we've been working on for a long time. And it's not completely new in the sense that it's a technique that was developed first at the synchrotrons around the world. But the new thing, of course, is that we've been working hard on trying to expand this technology in such a way that it becomes accessible for a much broader audience. And to do that, we're taking advantage of the platform of the X-ray Versa that is very similar to synchrotron setups. So that allows us to actually take something that was very demanding from a synchrotron point of view to make it an easy tool on a laboratory system. So this is something that we're very excited to be doing jointly together with Zeiss.
So that means that people can then apply this technology in their own lab without needing to go to the synchrotron.
Absolutely, and it complements well with existing laboratory techniques like EBSD, which primarily has been in a 2D kind of fashion or 3D with having to polish. But with LabDCT, you are able to do the similar crystallographic imaging, but in much larger volumes. So EBSD is still kind of on the microns, sizes of volumes, but we can do much larger with the X-rays in terms of millimeter size volumes. So you get much more information, but can still do the high resolution complementary work with EBSD.
Yeah, so this comes back to this whole idea that Zeiss is a multi-length scale solution for whatever the problem you might be facing.
science, right? So we are, in this multi-scale journey in terms of there's no one Swiss Army knife of a microscope, and how do we, efficiently help our researchers work through those together is definitely what we are focusing our solutions on.
Great. Well, I'm sure if anybody has questions, they can come check it out on the website. And thanks for taking the time to talk to Microscopy and Analysis.
Okay.
Thank you.
Thank you.